I deal with many of these items in the Unit 3 sample work video, but I want to make sure that we have in context the ideas behind conditional statements and logic. All right, so we're going to kind of build on the conditional statements and go from there. All right, so logic is built on this thing called a conditional statement. Let me give you an example. Conditional. Okay, we'll just shorten it to the word conditional. Also known as an if-then statement. Okay, you can think of lots of examples. If I study for the test, then I will get a good grade. If it rains, then the ground will be wet. If the Dodgers win the playoffs, then they will go to the World Series. I'm a Dodger fan, so that popped into my head. Right? If then, and that's the key. If then. Now, if then statements can be written without the words if and then. So, for example, if I have a square, then I have a quadrilateral. Could be stated as squares or quadrilaterals, but really, to be clear, as a conditional, we want to write it as an if-then statement. If I have a square, then I have a quadrilateral. Okay, I'm going to give you an example here of a conditional that we're going to work with. So if, and I'm going to shorten the wording here. It won't come across as proper English, but if I have a Dalmatian, then I have a dog. Okay, if I have a Dalmatian, then I have a dog. I'm just going to shorten that. If Dalmatian, then dog. Okay, this is what's known as a conditional statement, and this has parts. And here are the parts. The if part of the statement is called the hypothesis. Not to be confused with a scientific hypothesis, which is a reasonable guess about what you think is true that might be tested in an experiment. That's not the hypothesis we're talking about. We're talking about a logic hypothesis, which is the assumed statement. If a Dalmatian, that is, given that I have a Dalmatian, the conclusion that I have a dog must follow, right? The hypothesis is the if part, or the given part of the statement. Dog. Okay, then dog. The conclusion is what follows from the given. Conclusion. So, if I have a Dalmatian, then I have a dog. The hypothesis is Dalmatian. The conclusion is dog. I'm going to shorten this notation here a little bit. And I'm going to say Dalmatian is statement A and dog is statement B. Okay? And there's a little bit of a notation that goes along with this. We say A implies B. A, and the arrow stands for implies B. If I have A, then B must follow. Okay? So that's kind of the idea behind this reasoning. Now there is something called truth value, all right? Truth value. And we talk about this more in the definition of the sample work video. But truth value is whether or not the statement is true. If I have a Dalmatian, is it true that I necessarily have a dog? And the answer to this question is true. Yes. So this has a truth value of true. Okay, truth value. Okay, and we can, if a statement is false, we can verify it as false by providing what's known as a counterexample. That's something I'm going to get to here in a minute. Okay, so conditional, an if-then statement. An if part is a hypothesis, a then part is a conclusion. The hypothesis implies the conclusion, and the if the conditional statement can be true or it can be false. If it is true, then the hypothesis necessarily leads to the conclusion. Okay, let's go to another word here, and that is a what we call a converse. Converse. And I'm going to rewrite this statement. I'm going to say if I have a dog, then I have a Dalmatian. One of the most common philosophical mistakes is to assume both these statements mean the same thing. If I have a dog, then I have a Dalmatian. If I have a dog, it may occur to you that I don't necessarily have a Dalmatian, right? And by the way, the symbol for this is B implies A. Okay? In the converse, we switch the hypothesis and the conclusion. We switch the hypothesis and the conclusion. Okay? So this is now B implies A. If I have a dog, then I have a Dalmatian. That has a truth value of false. It's false because I can think of at least one counterexample. Okay? Counterexample. Let me give you an example of a counterexample. A counterexample would be a German Shepherd. A German Shepherd is a dog, so it makes that part true, but it is not a Dalmatian. So those are the hallmarks of a good counterexample. It makes the hypothesis true, but it makes the conclusion false. So a German Shepherd is a good counterexample. It proves my statement to be false. Let me give you an example of something that's not a good counterexample. A hyena. A hyena is not a good counterexample because a hyena is not a dog. And yes, it may not be a Dalmatian, but it proves nothing in regard to my statement, which is if I have a dog, then I have a Dalmatian. Okay? A good counterexample must make the hypothesis true and the conclusion false. Okay? Make the hypothesis true and the conclusion false. Okay? That leads me to another vocabulary word, and that is the word negation. Negation. Okay, the most common way to apply negation is the word not, right? And so if I say something is not a Dalmatian, then I'm saying it is outside of the group called Dalmatians. It is outside of the group of Dalmatians. It is something other than a Dalmatian. Note that negation does not mean opposite. So the negation of dog is not cat. Okay? The negation of dog is not rock. The negation of dog is anything that's not a dog. All things that are not a dog. And the symbol for that, the symbol for not Dalmatian, is the tilde sign, A. Okay, note that this is not a conditional statement. This is a word that we're going to now apply. Okay, it is not a Dalmatian, tilde A. So that brings us up to this statement here. We've done converse, where we switch the hypothesis and conclusion. Now we're going to do inverse. Inverse. And here's what an inverse statement looks like. If it is not a Dalmatian, then it is not a dog. If it's not a Dalmatian, then it's not a dog. The symbol for this, not A, implies not B. Okay? If it's not a Dalmatian, it's not a dog. Okay? I can think of at least one counterexample, so this statement is false. And from my counterexample, my previous counterexample was German Shepherd. Okay, I'm going to think of an animal that is not a Dalmatian, right? And I'm going to say German Shepherd again. A German Shepherd is not a Dalmatian, but it is a dog. Therefore, it makes the not a Dalmatian true, Not a Dalmatian is true, while not a dog is false. If you make the hypothesis true with your example and the conclusion false, you have proven the conditional statement to be false by providing a counterexample. So the inverse, if it's not a Dalmatian, then it's not a dog, is a false statement. Okay? Let's go on with one more. There's one more word here we need to know. Contrapositive. Contrapositive. And here's what the contrapositive of the original statement looks like. If it is not a dog, then it is not a Dalmatian. If it is not a dog, then it is not a Dalmatian. The symbols for this are not B implies not A. You notice what's happened. We've negated both the hypothesis and conclusion, and we've switched the arguments. We've kind of combined both the inverse and the converse into one statement. You might say it is the inverse of the converse, or it is the converse of the inverse. Okay? Switch and negate. And what's really kind of interesting about this one is this statement is true. If I don't have a dog, then I necessarily don't have a Dalmatian. Because if I don't have a dog, Dalmatians are inside the set of dogs. And if I'm outside the set of dogs, I cannot be inside the set of Dalmatians. This makes a lot more sense when we look at it through the eyes of something called a Venn diagram. And so let me bring up a Venn diagram here. Okay, Venn diagram. V-E-N-N diagram. Basically what a Venn diagram is kind of a way to depict sets. Okay, so here let this oval represent the set of all dogs. So German Shepherds are in here, Poodles are in here, Chihuahuas are in here, though some might argue against a Chihuahua being a dog. It is officially a dog, descended from the Timberwolf, believe it or not. Okay, and no disrespect to Chihuahua lovers. All right, so all dogs fit in this circle. As a subset of dogs, as a member of the dog family, so to speak, there is inside the set of dogs the set of Dalmatians. Dalmatians. And it's possible to analyze each one of these statements in the eyes of the Venn diagram. For example, statement number 1, right? If it's a Dalmatian, if I'm inside the Dalmatian circle, if I'm in this circle, this Venn diagram, this ellipse, am I necessarily in the dog circle? Is being in the Dalmatian circle being in the dog circle? It's kind of like saying, if I'm in the bedroom, am I in the house, right? The bedroom is part of the house, therefore being in the bedroom is being in the house. Being in the Dalmatian set is being in the dog set. Therefore, the Venn diagram verifies this is true. Okay? Look at the next statement. If a dog, then a Dalmatian. If I'm in the house, if I'm in the dog circle, am I necessarily in the Dalmatian circle? If I'm in the house, am I in the bathroom? Not necessarily. There's lots of places I could be. I could be in the living room. I could be in the kitchen. I could be in the set of German Shepherds, which is the counterexample I gave, German Shepherds, right? A German Shepherd is in the dog circle, but it's not in the Dalmatian circle. Therefore, this is false. Okay? Likewise, the inverse. If I'm not a Dalmatian, then I'm not a dog. So if I'm outside, let me shade. If I'm outside the Dalmatian circle, then I'm outside the dog circle, right? And this is actually misrepresented. If I'm outside the Dalmatian circle, everything that's not a Dalmatian, then I am not in the dog circle. Well, obviously German Shepherd's in the dog circle, but it's not in the Dalmatian circle. Therefore, my statement is false. The inverse statement is false. Okay, inverse, false. Okay, let's use the Venn diagram to help evaluate the contrapositive. If I'm not a dog, so if I'm outside the dog circle, if I'm outside the dog circle, if I'm not in the house, so to speak, then I'm not in the bedroom. If I'm not in the dog circle, I am necessarily not in the Dalmatian circle, and this verifies the contrapositive statement as true. Okay? Hopefully that makes sense. Okay? Now, I want to address, actually, you know what? I'm going to save this for a later video. I want to address biconditionals and definitions on the next video. So hopefully this makes sense.